Hello there. Today we'll be doing Sudoku Solver. This is a pretty difficult problem. In Sudoku Solver, we are given a puzzle where it's partially filled, 9 by 9, and we're gonna have to fill it out. I'm pretty sure you guys know how Sudoku works. We just have to fill it out from make sure it's each row is 1 through 9 and columns 1 through 9 and the box is 1 through 9. So that's our validation check. The way we're gonna do it is that we're gonna do a backtracking. So that basically means we're gonna go through every single possibility. Um, and yeah, so we're gonna go through every single possibility starting from the first item in the row and set that as a possible number, valid number. And then we're gonna start from this particular point after the, setting our row and column and starting from the first item as well. And we're gonna go from like 1 through 9 and try every single item. So an example, I'm gonna try doing the first two. I already have a couple numbers here that I've written up. This particular number has to be a 4 because there's a 1, there's a 2, and there's a 3 in here, so it has to be a 4. And then we go to the next number. Then we try 1, 2, 3, 4, validate all the numbers, and we find out that we can only put a 6 here, and so on and so forth, and we get all the way to the end of the matrix, going by every row and every column. There is an issue if we do happen to end up in a place where we are returning false for our backtracking. We've tried every single possibility, but there seems to be no solution there. We'll backtrack to the previous item and try again with a different guess and make sure that we exhaust all the possibilities. When we have returned to our first guess, here in our first guess, the highlighted in yellow, that it's just not possible. And that's it. That's backtracking. So here we go. So first thing we're gonna do is we're gonna create the backtracking function. What's going to happen is that we need a row and column in our backtracking function because we want to record where our backtracking begins and ends. We also know that we want to return a boolean because we want to know when the backtracking starts and ends or it has failed. So we're going to grab the row column and does not equal 0. So as long as there's a 0 in this item, as long as it's not a 0, we're gonna keep pushing and checking every row, checking every column. If it's gonna be a item in there. So C R. So once we hit column 9, we're gonna check. We're gonna move to the next row and check that one, and we're gonna continue until row is equal to 9. If it is ever 9, then it is going to be true. It must be true because we have reached the end of our matrix, and that's what it is. It's over. What we need to do is over. So now that we're done with we're checking every single item, let's start checking every single item. So for a guess, we're gonna make a guess in the range of if we do a random generated number, we might actually be faster because we don't have to like start from 1. Maybe even starting from 9 won't be faster, but we can try that later. So if self is valid, we need a function that tells us if our guess is a valid guess or invalid guess. I mean, we could possibly do this here, but that would be just a little bit too messy. If it is correct, we're gonna set that particular item to the guess because we know it's good. So after that, we want to check if the self.backtrack of this particular matrix at this particular row and column. We're going to start this row and column and make sure that we go to the next. We're gonna start from this row and column and go to the next item and next item. And if that is true, we can return true. So basically, this is recursion. We're gonna keep recursing, trying the next state and the next state. So once we will get back if it's ever true. If it's not true, right? If it's not true, then we will need to reset our current item and restart our guess again. So we're going to set it to 0, and we're going to find our number again, find a 0. We're going to see, oh look, there's a 0 again. Oh no. And we will have to restart our guess. Right. So anyways, return false. And yeah, return false. So then the false will be here, and then we'll restart the guess. So anyways, that's done with the backtracking. That's all we have to do. We're going to do is valid. Get the self, get the matrix in there, get the guess, get the row, and get the column, right? Return the boolean, and that's it. So we're gonna do the first row and the first column now. So I mean, not the first row, the row and the column. So there's this handy function called any. What any does is that it checks if any of these items matches up with this item. It's going to return true or false, right? So in any case, but yeah, we don't want to return immediately. So we're going to check if it is, then we're going to return. So if the row, and check every single column, j equals guess in for j in range of 9, so 0 through 9, and return false. Same thing if any matrix of I column equals guess for I in range of 9, return false. And lastly, we need to find out which box we're in. So to find out the particular box for row, start, and a column start, we need to set our row, hard division by 3 and times 3. What this does is it floors our current item to its most basic state. So from anything from 0 to 3 will be floored. Well, 0 to 2 will be floored to 0. Anything from 3 to 5 will be floored to 1. Anything from 6 to 8 will be floored to 2, and then we can multiply it. Same thing with our columns. We need to floor it so we can get the particular box where we start. Once we get that, we can start using the same any method. Method, we're going to check I and j. We're going to check every single item that's possible. What's going to happen is that for I in range row start, the row start plus 3, and basically we're going to do a for j in range column start and column start plus 3. Okay, hopefully that makes a lot of sense to you. We're going to return false at this point. If it's found, guess, of course, we're going to return true. Once that is done, we can assert that the self.backtracking of the matrix starting at 0, 0. That's where our starting point is. Actually, I mean, we can start anywhere we want, but based on our code, we start at 0, 0. So return the matrix after we're done, and run. Oh, runtime error. Row is not defined. Right. This is row, and this is column. Right. Matrix is not defined, and that is, what line is that? 30. Matrix. Run. Okay, accepted, and let's run it. Perfect. So that is backtracking for the Sudoku solver. Let me just empty this out a little bit more. Maybe you can see the entirety of this code, hopefully. Oh, you don't need the solve part. Let's just grab that section right there. That's what you need. And we can actually shrink it so we can get it onto one page. It's just a lot easier to code when you have a lot more space, you know how it is. So here we are. Of course, those where it needs to be spaced, it has to be spaced. But that's everything on one page. Let's erase these marks here. We don't need that. Anything else we can do? Right, the random. Making sure that the guess is in a random state. Or we start at let's say let's try it. So we're gonna start at 9, and we're gonna go all the way until 1, and we're gonna do -1. Let's run it. All right. Ooh, that's slow. Oh my goodness. Looks like going in reverse didn't quite go as planned. Right. Anyways, here we are. That was pretty fun. I hope you learned something today with the Sudoku Solver and how backtracking works. And I hope you enjoyed the video. Please like and subscribe if you did. And comment below if you have any questions. And check out the link in the description below for more algos and what I'm doing. That's all. Thank you very much. Have a good one.